Hello there, I'm Thomas, the pilot captain flying the Boeing 737-800 NGX of the PNDC simulation tonight, flight from Aviator International Airport. We're going to be flying Switzerland and Germany, then coming back in the Lszh Aviator International Airport. We're going to fly for level 250 or 35,000 feet, Mach 0.78 or 335 knots, and right now I'm in the cockpit for the pre-takeoff preparation. I'm going to show you some of the aircraft systems like the flight control, the control code, the control we use for the flight control surfaces like the ailerons and the spoilers, the elevator, the horizontal stabilizer trim, the rudder trim, the aileron trim, the throttle levers, the engine function. So I'm going to show you the engines and how they work. I'm going to show you the speed brake, the start lever. I'm going to show you the autopilot, the climb direction system, the autopilot unit, and the auto thrust. I'm going to show you the displays, the primary flight display, the navigation display. We have the horizontal situation of the aircraft and the vertical situation. We have the airspeed and the altitude. We have the modes from the autopilot and the auto thrust. We have the auto modes are selected from the autopilot unit. We have the flight management computer I'm going to use before takeoff when setting up a flight management computer and a flight on a flight path. I'm going to show you the overhead panel systems like the fuel tanks and wing, left wing, right wing, and further down the fuel level and the fuel level and the pumps we use. I'm going to show you the electrical system, the RS, the data network reference system with the GPS controllers and the inertial acceleration gyroscope and deceleration gyroscope, and also the magnetic and control bus and clear data from the pitot static and pitot metric and the envelope stack of the aircraft on the flight. And this is for the air data inertial reference system, which is used to supply the navigation displays and the flight management navigation sources. So I'm going to show you all the systems. Also I'm going to show you the electrical panel, the IDGs, the integrated drive generators from the engine. I'm going to show you also some other systems of the top time, like the air panel, the cabin pressurization panel. I'm going to have to do it very, very fast and set up the flight management computers. Like I'm going to make a smooth flight because I have not much time. So I'm going to start right now. I'm going to show you also the air system, the cabin pressurization, the ADI, some navigation sources, and thank you very much for joining this flight. So you can see here we have I'm also gonna make a small engine start demonstration very fast. So here we have the cockpit. We have here's the control wheel and control column. Control wheel, control column, control elevator up and down, and bang roll, spoilers and ailerons. Left and right we can see the speed guidance when we fly over here, the bang roll and the pitch attitude, the pitch ladder. So here we have I have the side stick I used to simulate that the control wheel of the aircraft and the Boeing. So this is for the Airbus. I use also for the Boeing. We have the pitch stream wheel here and the flaps and the thrust levers, some other functions. So pitching up and down the elevator, the control column, or bang rolling left and right, the ailerons and the spoilers. So you can see here, if I come in the outside view, you're gonna see here the rudder and the elevator, bang roll, the aileron, the elevator, pitch up and pitch down, you can see here, and the rudder left and right on the aircraft using the rudder pedals. So this is so much for the flight controls. I'm gonna come now inside and show you some of the systems. This is so much for the flight controls. We have like maybe if we are lucky we have like 40 minutes of flight maybe. So we need to be very fast. Here's the primary flight display. Here's the airspeed display right now. Ground speed is 0. Barometric altitude above sea level 1,400 feet. Radio altitude 0 feet. The pitch ladder in degrees 2.5, 5, 7.5, 10 degrees. Positive or negative. Climb or descent. The bang roll in degrees So we have here like 30, maybe 45, 35 degrees. We have maybe like 20, 25 degrees here. So we also have the altitude selected here, 4,000 feet. Here's the rate of climb in thousands of feet or hundreds of feet per minute, or the rate of descent of the aircraft. So this we have to be very careful with that. And the altitude. So this is the altitude selected right now. Here is the airspeed selected, 150 knots at 4,000 feet. Here is the navigation display, 4,000 feet. Parametric altitude. We have some terrain, some mountains in front of us. We have the terrain in front with yellow. This changes with range. So if we have terrain in front of us about the same level is yellow, below us is green, and above us is red. So you can see yellow is same level and a little bit higher, and red is dangerous, it's a lot higher, it's gonna demand a higher rate of climb. As you can see in this distance, like 20 nautical miles, we have a lot of mountains in front of us. So this is the terrain, the elevation 7,600 maximum, 400 feet minimum traffic. We have aircraft display over here. We can see we have the autopilot unit. Here is for the displays, the control. You can see the warm up. You can see some airports we can display over here. We can display the terrain, so we have airports right now. So that's good work. Here's the airports with blue cycles. So I'm gonna set up later this the autopilot. So you have the auto thrust, the flight director, the airspeed, the heading, the altitude, the vertical speed, and the autopilot command for control with steering command, and the autopilot disengage switch. Here's the landing gear. Remove this to retract or extend the landing gear. The auto brakes, the flaps and flaps lever position. We're gonna retract the flap to 0 for starting the engine. So I'm gonna come here very quickly. We have the speed braking stand here, so you can see the speed brake over here in the wing. And this view is looking better. This is the speed brake stand now. So I'm gonna retract the speed brake. Here is the thrust lever. You can see this is the takeoff go around switch. Here's the auto thrust disconnect. Here's the thrust reverse. If I move this down and up into the idle and up, I engage the reverse thrust. You can see here we have the reverse thrust. 29.8% maximum, 8%. So you can see here the reverse blocker doors here. They're open. So this is gonna slow down the aircraft in flight. So we got something with the weather. Okay, it didn't load. So we have to reload it maybe. I'm not sure. It's not loading in the condition that I like it to have. So we go very fast. Have not much time. Got like 35 plus 10 minutes. So I'm gonna show you here. We have I told you the thrust levers. You can see the dent and the thrust levers now is in the idle. We have the flight dented. We have 50% here flight dented. We retract the reverse. Flight dented 50%. Maximum takeoff go around. So you can see. Here's the pitch trim wheel. We use this to balance the aircraft in flight using the horizontal stabilizer. Here, the tail of the aircraft position. It's angle of attack to pitch up and down horizontally with respect to the airflow. And this balances the barometric pressure, the dynamic pressure in the wing, above the wing, the forward wing. Increases or decreases the lift. So, and changes the center of gravity position. With respect of aerodynamic chord. So this about aeronautics engineering. So I'm gonna be very fast right now. I have no time to explain everything. Maybe a little bit lessons. If you have a control we We have this the rudder pedals, as you can see. I'm using this to control the rudder pedals and control wheel again. No problem with that. We have the rudder, the tiller here to control the nose wheel of the aircraft, and we use this switch here for the nose wheel steering, normal or alternate. We have two modes. Don't remember the configuration. So we have the chrono time here. We have the navigation display. I told you we have the GPS here with the airports, the terrain, the map, the weather radar, the air traffic. We have the side mounted computers here. This mounts the aircraft in flight. So if I come over here, I will show you the overhead panel. I have to be very fast for this starting up the engine. So we also have here some other controls like the elevator pitch, the pitch stream here, the autopilot disconnect, the aileron stream over here in the control. We also have the rudder trim here, this way. We have the transponder here, the radio communication panel here in here. We have the fire extinguishers here. We have the stabilizer cutout screen here. So I'm gonna show you now a little bit of the overhead panel. We have the fuel pumps here, so maybe I'm gonna show you a better view of that. We have the exit now, the exit valve, fuel pumps. We have low we have low fuel pressure, low fuel quantity here, so we're gonna increase a little bit the fuel level in this old tank. 36% in total. in total fuel, so this is gonna be very helpful for this flight. Return payload menu, I can see. So maybe we need to start the engine. Now we're gonna have no display like that. We have here the fuel temperature. We have the fuel pumps, the left and the right wing, and the center tank in the fuselage. So we also have the navigation display sources. We have alternate flaps and slats. We have the air data inertial reference system that I have been telling you has the flight control computer. They have the electronic computers from the engines here. We have the electrical panel over here, the integrated drive generators for alternate current, the displays of the electricity, and the conductors of the electrical panel. Here we can use the APU for instance. The APU is in line. We have to use this button here, this switch, to start the APU in flight or here in the ground. So it's already started. We have the exhaust gas temperature high. This is starter for the engine. So I'm gonna come only this view here, upper panel. Here we have it. We have here the display. There's a little bit more lighting here. We have the display. You can see. This is for the GPS, the gyroscopic acceleration, the air data from the pitot static and the pitot anemometric, the airspeed and the altitude and the GPS position, gyroscopic and acceleration and deceleration rate, magnetic fuel compass, alignment is this one. We have the CPS frequency and volts here. We have the electrical panel, so we can change the configuration here. We have a little bit more time for this. So we have the battery here display. We have the APU generator 1, generator 2. We have 150 volts, 400 Hz, and the same for the left engine. And if we use the transformer rectifier, we have amperes. Transformed from the alternate current to direct current, 48 amperes, or 46 amperes, 150 volts, up 102 Hz. We can use many configurations here. This panel, by switching this, using this switch, converting alternate current to direct current to the transformer rectifier, or alternate or direct current. 117 volts, 400 Hz from the battery with this volt. We can use also generator 2, generator, active generator. Here's the battery conductor, it should be on. We have the standby disconnect for the IDG. We use it like that, the standby battery in the auto, and the bus trans is on. And also we have the generator conductors here and the APU. We have the APU connected here by default. So this is the cabin pressurization. You can see the cabin altitude in 1000 feet and the differential pressure to go to 8.7 psi for 40,000 feet. The cabin rate climb or descent for pressurizing the cabin. You can see pressure difference. We need to take off and landing, and if we fly like 35,000 feet right now, we're gonna have 4,000 altitude. We have 2,000 set the landing altitude, and also we have the controller here. We change from auto now. We have the auto function of the pressurization panel. We put change in the alternate one or manual. Manual, we pressurize the cabin using the switch as we climb or descend, and watch this controller here change. So we leave in the auto. Going back here, we have this hydraulic switches here. We have the engine anti-ice and the wing anti-ice. We turn the wing anti-ice on. We need some wing anti-ice. We have the overheat, electrical 1 and 2, left wing engine 1 and 2, hydraulic pumps and electrical pumps. That here's the window heat. We need to turn this off for starting the engines in the ground. Here's the pressurization panels from the APU. We turn off the engines, and the APU is gonna see here going down the pressurizer. There's no pressurizer right now because it's 0. We need pressurizer from some systems like starting the engine for the pressurizing the cabin. We turn on the APU, see we have pressurizer. Turn the left wing engine using the auto and close the packs for starting the left wing engine. Here's the air conditioning panel. I told you, here's the electronic engine controllers for the engines, the paddocks. We have computers to control fully digital electronic control computers to monitor and display. Over here we move the thrust levers. Everything is being monitored and displayed by computers and managed by computers, paddocks. And also from there, data inertial reference system set here into the display system. So we have like, if we are like maybe 40 more minutes of flight. Thank you very much for joining. This is the control wheel. Fluts and flaps here, we can control here in the side also. So we go back inside the parking brakes. Here is the stabilizer trim cutout switches. We lose the electrical trim from the autopilot. We could turn off the switches here and follow the autopilot. Here's a radio communication panel on the fire extinguisher. I haven't shown you. So here's the engine start selectors, left and right engine, and the ignition, both the wipers from the wings and the lights, exterior lights that should be on, and some interior lights. So I'll let it light. So this is so much for the cockpit. It's gone very quickly. Starting the engines now. Maybe coming in this view. Virtual cockpit view. So I'm gonna show you. I'm gonna turn off the fuel cutoff levers here, both of them, left engine and right engine. I'm gonna lose both engines now. You're gonna see the low oil pressure, and the engine system is slowing down. You're gonna see the engine stop spinning in a while. The right wing and the left wing engine. You will have them both slow down in a while. So we come here again. You can see it's going off now. Lower pressure. And we have the indications that we want. So we come over here and this configuration for the pressurization panel is okay. Over here we need pressurizer for the engine starter, so we start the left wing engine first. We isolate the left and the right engine first, pressurizer. So we're gonna have the message here, VN1, low oil pressure, and the start valve is open. So we have the N1 increasing the temperature, fuel flow is 0. We need to start the fuel cutoff lever. So the N2, which is the high pressure, high speed rotor state of the engine, of the turbofan engine stage, 27 point. Above 20% we can start the fuel flow. We're gonna have ignition into the engine. We have the left wing engine, as you can see, start spinning. The right wing is off. Here is small rotation here, small level of rotation. So we go back here and start the left wing. Cutoff lever, 38%, we have the start valve open. Message, we initiate the start. Now you can see the N2 increases rapidly, and here we have it. The engine goes speed, as you can see. Have the engine speed is ready. We can start the other side engine now. We only need we can use this window heat on again now. We have electrical now. A lot. We can connect the engine, the left engine. Here we have a lot of electrical. Then we can turn on this switch, leave this this position. So we have now start the right wing engine. This wing engine, we go in this mode, ground. So we're gonna have the right wing engine now. Compressor, the FADEC, the full authority engine control computer, is gonna control and monitor everything. We have like maybe 30 more minutes for this flight. Engine 2 is increasing. We have an 2 increases here. We have spinning, positive spinning for the engine. The left wing, the right wing going on now. So we use this view now. You see here the spinning. We have a slow spin for the engine start. So we come over here and just use this fuel cutoff lever in the on position. So we're gonna have the messages here going very quickly. Start valve is open and low oil pressure, and we have the ignition for the right wing engine. Here we go. Start spinning. As you can see. Here we go. We have the right wing engine on. So this is so much for the starting of the engine. We're going very fast to start the aircraft. We use flaps back into position like I don't know, 1, 5, 10, 15. Stabilizer trim into position 3.8 for the takeoff. Thus using this flight management computer, we use the initialize here position LSZ8 reference airport, LSZ8 Zurich International Airport, and do this. You can see the GPS position, the coordinates here from the air data inertial references system as shown before. So we have position, we have route from LSZ8. Maybe before we need to do the route from LSZ8 to LSZ8. You're gonna see here in the map everything, the whole flight plan. Runway 14. Runway, departure and arrival runways, departure 14, you know the trans do it to alpha. We're gonna have the flight path here, so decrease maybe the range a little bit. We have better view here of the range and the mountains you can see in front of us is into alpha. Departure, arrival, LS14, LS localizer, Transnegria, transonic. So we're gonna have this flight path here. For this flight, you can see the mountains, you can see the air modes you're gonna see in a while. So we start initialize the fuel. Zero fuel weight, gross weight 133,500, zero fuel 121,500, fuel weight about maybe like 11,000 pounds. 5 pounds. So we have cruising altitude 25,000 feet. We're gonna use our own, and we want limit flaps takeoff 15 degrees flaps. Here we have 15 degrees flaps. Center of gravity position 21.9%, trim 3.85, and V1 precision speed rotate 127 and takeoff speed 138. With this center of gravity trim position 3.81, and these flaps settings here. So we go here in the autopilot section. We're gonna turn on the auto thrust and the airspeed increase a little bit, and we are ready to take off actually. We need not to lose too much time. Maybe we're gonna use the L-nav function, I'm not sure, and increase the altitude also to 35,000. Higher altitude than that. We have maybe like 25 minutes, 30 minutes for this flight, hopefully. Not losing too much time. We have the display of the traffic. So here you can see the flight path we're gonna follow here, the waypoint from GPS over the flight path for the legs. Initialize, here we are, load weight, launch fuel, here we have it. Just activate everything, we don't need this discontinuity, activate here and execute. And here we go, we have a ready magenta purple line here, pink line. So we're gonna fly like that over here, this is good. So we're ready to go, I believe. We have like maybe 30 more minutes for flying, if we are lucky. So we go over here, we have an outside view here where we are. So where are we going? We're in the Zurich International Airport right now, and we're going for a small flight. Thank you for joining. Let's go back. 737-800, Boeing 737-800. So we go back. This view, sure. So we're gonna use this tiller to steer the aircraft. Disconnect the parking brake. Use some thrust here. Parking brake disconnect. You can see how I use the tiller and the rudder pedal to steer the aircraft. Decrease the thrust now. So we have no traffic now. Into the airport. So we need to hold here and wait to see if there is traffic and ask the controllers, but no traffic right now, no display. So we're going directly for takeoff. We have the auto thrust, the autopilot set, the altitude hold. This is how you use the tiller and nose wheel. Hold parking brake for a second. Come outside here, maybe use one more view here, the runway. Ready for takeoff, 30 more minutes. So we come closer view here, maybe. Now we're going to accelerate to the runway. So we have the autopilot set correctly. The LNAV maybe, altitude, maybe speed, I'm not sure. So we have thrust levers here, increase the thrust. You can use also the takeoff go around mode. So you can see here the thrust increases, the N1 increase. We have here the modes from the autopilot, the auto thrust is on. We have the airspeed, then we're gonna fly in the altitude. and the radio altitude, the barometric altitude. Here's the display, the waypoints we're gonna follow as we take off and glide and move this way and back into the airport and the terrain in front of us. So the flaps are ready, everything is ready. We can just maybe disconnect the parking brakes and go. $50 knots. 80 knots, 92 knots, 120, 127 we rotate. Here we are, we rotate, and V2 we take off. Here we go. We have positive glide, retract the landing gear now. So I'm gonna show you how we climb here, climb out. And we have like 30 more minutes for this flight. So thank you very much for joining. So here we have the modes here. As we climb out, we are just 500 feet above the ground level right now. Keep climbing up. 1000 feet per minute, maybe we're going to increase that. You can see the radio altitude here, 500 feet above the ground level, but 2300 above the sea level. So we have the mode control panel, the altitude hold, the airspeed sheet, we do the 7 knots, the rate of climb on the sun. Keep climbing here, 700 feet, 1700, keep on going. Fixing out a little bit. We are very low right now. Keep climbing. You can see the terrain here, the terrain function. I want to say you can see how close we are flying into the terrain of some mountains. We have to avoid. We're just 1,400 feet above the ground right now, according to the radio. So we're gonna increase this climb. Track some shots. 30 more minutes for this flight. So thank you for joining. 35 more minutes. Keep turning like that. We have 4,000 feet right now above the ground level. You can see the terrain here. "35 more minutes for this flight. Thank you for joining." So here is the climb out for the Boeing 737. We retracted the line here. Maybe 30 more minutes for this flight. Not sure. Here's the altitude, very calm, Switzerland. Have a lot of snow here. And nice view. It's climbing up. We're flying manually right now, no autopilot. This is how stable this aircraft is. Our max speed is 0.438. I'll keep climbing up. Maybe we drag some more flaps. We don't need so many. Maybe increase the airspeed a little bit. The airlock, maybe we need to connect here to the airlock. We're going back now. Controller, so maybe drop this. It's a 20 meter actually. So it is nice. slow. Flying direct now into the next waypoint. Here climbing 12,000 feet. We have like, I don't know, maybe 30 more minutes for this flight, hopefully. Interact maybe more flat into position. To track them up. There is many flat made. So now we're gonna increase our airspeed. Need like a higher rate of climb right now. So here is the autopilot unit, as you can see. The mode control panel, the primary flight display, the flight mode annunciator, the rate of climb right now, 14,000 feet, you can see, it's climbing. We need to decrease the lighting here, slowing down our graphics display. The subframe meter, the lights from the display. So we keep climbing here, as you can see, past 18,000 feet maybe, airspeed keep ready 5 to the knots, 0.486 Mach. So we need like 30 more minutes, hopefully, and we're gonna be climbing up more higher. Have a nice view here. And this Switzerland going into Germany. This is Germany this way. Have the same travel plate. Climbing up 90,000 feet. We have the airspeed off. The selected thrust here 93%. Small Bangalore. 15 more minutes for this flight. Good. Have a nice view. Maybe a few more airports here, high range. See another aircraft overflying us. Keep climbing up. We have the Germany here in the front with the display, navigation display. As we're going this way, maybe slow down the rate of climb a little bit. Past 33,000 feet now. Maybe we have the chemtrails now. Beautiful chemtrails. Correct. Have some chemtrails here displayed. You can see these vapors, nice vapors from the aircraft engine. Incline box. You can see the lake here, the St. Gallen, as I told you, region. 24,200 feet now. Maybe going to level off now. So you're gonna see the modes here change a little bit. Mode control panel, have the LNAV maybe, or not. So here we are to the 5,000 feet. Have like 15 more minutes for this flight. We're in good position. You can see the waypoints. We're gonna fly the horizontal and the vertical. Now we hold level here at this altitude here. Trying to balance down a little bit the pitch spring wheel using this to balance the aircraft manual control. So we're flying towards Germany now. We're gonna overfly the Bayern Munich region now. Maybe we'll see some visualization. Bavaria. Very close to us actually. Have not much time for everything, unfortunately. So we can see here the vapors from the aircraft, from the engine. Not very well because it's still day. It's not quite strong constantly. So we need maybe to turn back to the airport. Have like 15 more minutes left for this flight. We're going back into the airport now. This is direct to next city. We're going direct to maybe next one. Not lose time. So we can see that Germany now, we are flying Germany. We use the pilot function in a while. Turning here. Have like 15 more minutes to go for this flight. So I need to do this faster actually. Here we are 35,000 feet. Fifteen more minutes for this video. Need to turn around a little bit. Now we don't have the airport here in display. So, 3114. To fly direct to. Bring down 15 more minutes for this flight. We're gonna connect the autopilot, that's for showcasing command A. So now we have the command A. And the altitude hold commands here. So you can see here we have the autopilot on. Connected right now, maybe to increase the range a little bit, so a little bit more. Where we go right now, with the autopilot commands connected, we could be flying a little bit faster. Mach 0.776 or 335 knots. You can see the speed limits here. We have the command on. Up to level low. You see the autopilot controlling now off. Everything. All the controls like off. The control wheel. And the control column. This is now down there. So this is done automatically now. I'll just go back into the airport. So we have another maybe 15 more minutes for this flight if we are allowed to run. So here is the reason. Going with the autopilot, maybe increase the range a little bit again. Add some more. The airport with just 57, enough to come all the way. Increase the simulation rate. So he'll go a little bit fast. Let's save some time here. We have again the chemtrails again. Country. Here is the spacecraft that we fly with. To this flight, you can see Germany in the back, Switzerland, maybe France in this way. So we're going back. With the autopilot connected, maybe we need to descend in a while. Reach here 35,000 feet. It's fine. We'll have some night music in a while. Have the galaxy maybe in a while. So this is the Boeing 737-800. Normal flight. So we have like 10 more minutes for this flight. We need to start descending actually. So we decrease the air fixtures. And then the altitude. You can see the autopilot engaged here, command A. We will disengage later. Autopilot engaged, autopilot off, connection panel here, and the display. So we start descending up. Our level change here. And altitude call here. So we're gonna use also some speed boost. We need to have the flight director, and we control panel speed here now. Altitude hold to the 4,000. So we start descending. Increase the range a little bit. Have like maybe 8 more minutes for this to go. So we need to be a bit faster than that. 10 more minutes for this flight. Keep having some chemtrails now. be the last one. Entrance here. Have the galaxy now. Have been now with the galaxy. Here. Descending. We're flying the Lszh. The system. To the 1,500. So maybe rate of descent. Initially, performance, library performance, Flught be at 147. So we're going like that. To the runway, on the waypoint, the airport. So we have the fixes here. So we need to fly through. Maybe we're gonna use the ball localizer for the ILS approach. Maybe slowing down on the aircraft on this. Just moving speed like 250 knots an hour. 120 maybe. We use some shortcut as with the sun. To the runway. Basically we are into the runway region of the airport. Here. Here. Have like less than 10 minutes, 5 to 6 minutes more. Close 14,000 feet. We disconnect the autopilot now. So you have the control with steering now. So these are some stick brakes. Slow it down. 13,000 feet. Using the landing gear now. Slow it down. So this is gonna slow down the aircraft now. Going down, a little bit this one, need to be in line with the ILS localizer here. It's also a bit higher, so we need to increase the range. Keep descending here, closer into the runway now, 13,000 feet, coming in closer. Five more minutes for this flight, so we are in a very good position actually. You see the river here. You see the mountains. We have a display here. So we're just gonna slow it down a lot and also fly a little bit more level. Gonna use maybe 2 more notches of that, down to 15 maybe, 17. little bit higher in airspeed than it should be. I don't know why. So we're gonna use manual thrust maybe for this approach and landing. Oh, here we are. We have the runway side. So we have a computer performance not so good right now. It's slowing down. So here we have the Lszh localizer. Here we adjust a little bit higher, and we need to turn it to the right a little bit descent. We use idle thrust as we go. So here we are. For this descent path, maybe the simulation rate a little bit slower, using frame rates to become my life. Here we are aligned with the Lszh, as you can see here. Lszh localizer, the radio altitude 1,300 to 2,800 feet above the sea level, the airspeed, and the Lszh localizer, and the glide slope. So we keep descending, turning a little small alignment, going manually now, manual thrust. A few more feet to go. Here we are, just touched down the runway safely and securely. Parking brakes and reverse thrust. Let's come slow us down. Full reverse maybe. Here we are, just landed. Very safe landing, very professional. You can see the landing gear here, both of the landing gear wheels, the left and the right, and the nose wheel are normal. Τώρα έρχομαι. Περίμενε, έρχομαι. And the nose wheel are correctly safe. Ξέρω, τα πάω, μη φοβάσαι. Τους έχω πει. So the nose wheel is completely safe right now. There is no damage from the landing. So maybe put a little more light here to the nose wheel. So you can see here nose wheel, landing gear, the wings, everything is safe from this landing. The tires, the balloon tires, landing gear tires. So we can use this aircraft again for flight later. It was very nice flying here, only one for right, so got to go now. So that was some of the pilot flying down. So So that was Thomas, the pilot captain, finder. Boeing 737-800 into nice flight from Zurich to National Airport back to Zurich International. Flew at flight level 25,000 feet, Mach 0.766. We just landed at Zurich International Airport very safe. Thank you very much for watching. I'm gonna see you next time for the next flight, next episode. So thank you very much for watching this video. Bye bye. Bye.